Question 1. So remember, factorising means putting the brackets in. So we're going to have brackets in both A and B. It doesn't say factorise fully, so you're just going to be taking one number or letter outside on each occasion. So what's the biggest number that goes into both 10 and 25? That's 5. So 5 comes outside the bracket and open up the bracket. 5 times what gives us 10a? 5 times 2a gives us 10a. Get the sign right, it's a plus. 5 times what gives us 25. 5 times 5 gives us 25. Now for part B, there isn't a whole number that goes into both 7 and 4, so we can't take a number outside the bracket. It's only a W that we can take outside the bracket. So W open bracket. W times what gives us 7W squared? Well, that's 7W. W times 7W is 7W squared. Get the sign right, it's a minus. And W times what gives us 4W? Well, that's just a 4. Now for part C, remember expanding means getting rid of the brackets. So we multiply the p squared and multiply each of the terms in the bracket. P squared times p is p cubed. Get the sign right, it's a minus. P squared times 5 is 5p squared. Now for part D, expand and simplify. Well, expand means get rid of the brackets. Simplify means gathering up the like terms. So let's start off by the expanding. So we multiply x by both terms in the second bracket, then move on to the minus 3 and multiply that by both terms in the second bracket. X times x is x squared. X times plus 7 is 7x. Minus 3 times x is minus 3x. Minus 3 times plus 7 is minus 21. So that will give us 1 mark. We've expanded. Now the simplifying bit, you gather up the like terms. So the only like terms are the x's. 7x take away 3x is plus 4x. So our final answer, x squared plus 4x minus 21. Now for part E, we've just got to substitute 2 in for where f is. So it's 2 cubed, which is 8. And then we're going to take away 7 times 2, which is 14. 8 take away 14 is minus 6. Question 2. So we've got to enlarge the shape with scale factor 2, center 7, 3. So go to the center 7, 3, and then shape P, all the points are going to be twice as big, scale factor 2, but also twice as far away. So let's take this point here, for example. I'm going to call that x1, so the bottom right hand corner. That's presently 4 squares to the left, so we're going to double that from the center and make it 8 squares to the left. So that bottom right hand point there becomes this point here. So that's established the location for our new shape Q. We've now just got to make it twice as big. So all the lengths are going to be twice as big from this bottom right hand corner. So the base will no longer be 2, it's going to be 4. The height won't be 3, it will be 6. And 2 across, 4 down, 2 across, 2 down. Now for part B, we're going to rotate the shape 90 degrees anti-clockwise about the point 7, 3. So get your tracing paper out, pop it over shape P and the X. Draw, and yes, then the big tip, draw an arrowhead pointing upwards on the tracing paper. That really helps. Draw around the shape. Now go and put the pencil point on here, acting as a pivot, and move your tracing paper around until the tracing paper is now pointing to the left. So that would be a quarter turn anti-clockwise. Press through the shape, causing an indentation on the paper below. Remove the tracing paper and draw over it, and then just check you've got it in the right place. So establish this new shape R using tracing paper. I've forgotten to call it shape R. You should label that shape R. Question 3. So these are the ingredients for 4 people, and we need to basically find we need to make the crumble for 10 people. So we're really going to have to just scale up from 4 people to 10. So you can either just spot that it's 2.5 times as big and multiply by 2.5, or alternatively you can divide by 4 these numbers by 4 to go back to 1 person, and then multiply by 10 to get up to 10 people. So we're being asked to work out the number of apples he needs. So we need 300 grams of apples for 4 people. So divide this by 4, that tells us the amount of apple we need for 1, times by 10, that tells us how many grams of apple we need for 10. So 750 grams. Now for part B, he uses 920 grams of blackberries. Okay, so work out the number of people in the group. So 115 grams are needed of blackberries are needed for 4 people. Dividing this by 4, we can see we need 28.75 grams for 1 person. Now we've got 920 grams, so if we divide this by the 28.75, we can see that's enough for 32 people. Question 4. So part A, write down the modal class. Well, mode means most, so we need to find the class with the most. Well, the biggest frequency number is 14 leaves. So how long were these 14 leaves? They were between 3 and 4 centimeters. So your final answer is going to be copying down this bit here exactly. Okay, modal class, which number in this column is biggest, and then write down this number accordingly. Now for part B, we've got to work out an estimate for the mean. Now these 4 leaves, we know they're between 0 and 1 centimeters long, but we have no idea how long they actually are. So the best we can do is just assume they are halfway along. So halfway between 0 and 1 is 0.5. So we've estimated the length of these 4 leaves. We're going to pretend these 4 leaves are exactly 0.5 centimeters long. Similarly, we're going to pretend these 5 leaves are 1.5 centimeters long, and so on. So this is why we're doing an estimate, because of this initial assumption here. Now once we've made that assumption, we've just got to multiply across. So 4 leaves times half a centimeter each, that's 2 centimeters in total. 5 times 1.5, 7.5, and so on, giving us these subtotals here. We then add up that column, and that means that we're estimating that the total length of all the leaves is 113 centimeters. So how long is each leaf? Well, you take this 113 and divide this by the number of leaves, 40, giving us 2.825. The question asks for it to 1 decimal place, so our final answer is 2.8. Question 5. So use your calculator to work out the value of this, and write down all the figures on your calculator display. So simply pop this into your calculator. I would recommend that you use that fractions button, which is the 3rd one down on the left, where you've got that white rectangle divided by that black rectangle. And then just using the big blue arrow key in the center of the calculator, make sure the 7.3 plus the 2.1 is popped on top of the fraction, 6.4 is popped on the bottom, and then move out of the fraction by using the blue arrow to the right, and then just add on 2.2 squared. So that gives you 6.30875. So to 3 significant figures, that means you give 3 figures in your answer, 1, 2, 3. Do we round the 0 up? Yes, we do, because the next digit is 5 or above. So our final answer is 6.31. Question 6. So this is going to be a straight line graph, because we've just got y's, x's and numbers, no squares or cubes or anything. So we just really want to form a little table and just work out 2 or 3 values. So I would just suggest you just work out 2 or 3 of the easy x values. So maybe x being 0 or 1 or 2 and so on. So just pop in a few in the x column yourself, and then you're simply going to substitute these x values into the function, into the graph, and see what y values pop out. So for example, when x is 0, 2 lots of 0 is 0, 0 at 4 is 4. So when x is 0, y is 4. when x is 1. 2 lots of 1 is 2, 2 and 4 is 6. So when x is 1, y is 6. So you only need to do a couple to be sure, but I would do 2 or 3, 3 or 4 to be safe. But I wouldn't worry about doing the negative ones, just in case you make a mistake. Just stick to the easy positive ones and just plot those 2 or 3 coordinates. But what you must do is make sure when you get out your ruler and you draw in your straight line, you've covered the x values all the way from -3 to +3. So the line must cover the whole of the graph paper, but you don't need to have worked out each of these coordinates. Question 7. So a right-angled triangle, trying to work out a length when we're given an angle, so this is going to be SOHCAHTOA. So picture yourself at the angle. So this side is adjacent to me. The side I need to work out is the length AC, is the hypotenuse. So given we're dealing with the adjacent and the hypotenuse, we're going to be using cosine, cos. So cos the angle, cos 22 equals our adjacent side of 14.9 divided by our hypotenuse, which is our unknown length AC. So we've got to just do a little bit of algebra to sort this out. So first of all, multiply by AC, then divide by cos 22. So we get the length AC being 14.9 over cos 22. Pop this into your calculator and you get AC being 16.070 ... So to 3 significant figures, 1, 2, 3. Do we round the naught up? Yes, we do. So 16.1. Question 8. So we've got to work out the percentage increase in Donald's pay between 2014 and 2015. So now to work out a percentage increase, you need to divide the increase by the original amount and multiply this by 100. So the increase is from 66880 to 640, which is 28.8. Divide this by the original amount of 640, multiply that by 100, and you get 4.5%. Now for part B, we're told that Donald's weekly pay was 95% in 2015 compared to 2016. So let's gather our thoughts here. 2015, 2016, 100% of our weekly pay was in 2016, 95% was in 2015, and we know that our 2015 salary was 66880, so pop this into the 2015 column. So how do we scale up from 95 to 100? We divide by 95 and multiply by 100. So we need to follow that same scaling. So we take our £668.80 and we multiply that by 100 over 95, giving us $704. Question 9. So use ruler and compasses to construct the bisector of angle PQR. So we basically got to draw a line in here which halves this angle. So this is how you do it. You get your compass and you go and pop your pinhead here at Q, and you just do a small arc here. So this blue arc would be the first arc you do. Now this is just to establish a point here and here where you're going to go and put the pin of the compass next time around. So you then go and do a couple more arcs. They can be the same length as this arc, or they can be a new length, it's up to you. But the next 2 arcs, these 2 purple ones, do have to be the same length. So pop your pin here and draw a little arc, then move your pin down here and draw a second arc, and then get your ruler and draw a straight line from Q through where these 2 purple arcs cross, and that red line is your final answer. That is halving the angle PQR. It says you must show all your construction lines, so make sure you leave your blue arc and your purple arcs on the paper. Don't rub those out. Question 10. Now, in order to solve this simultaneous equation, we're going to need to have the same number of x's or the same number of y's. Now, I'm going to choose to line up my x's, so I have the same number of x's. So 2 times 5 is 10, so I need to have 10 x's on both of my new revised equations. So I'm going to choose to multiply the top equation by 5, That will give me an equation with 10x in it, and I'm going to choose to multiply the second equation by 2. That again will give me a new equation with 10 in it. So here we go. I'm taking the first equation, I'm multiplying everything by 5. I'm multiplying the 2x by 5 to get 10x, the 7y by 5 to get 35y, and the 31 by 5 to get 155. I'm then moving on to the second equation and doubling each of the terms, so 10x minus 6y and 32. Now, in order to eliminate the 10x's, I need to take them away from each other. So I'm going to take the bottom equation away from the top equation. So 10x take away 10x is nothing. That's the whole point. 35y minus 6y, so minusing a minus is a plus. So that's actually 35y plus 6y, which is 41y. And then 155 take away 32 is 123. So we've eliminated x. We know that 41y equals 123. So dividing both sides by 41, we get y equaling 3. Y equaling 3. Now, in order to work out x, I've really got to start again. So just take one of the equations you started with, whichever one you think just looks easiest. So I'm taking my 2x plus 7y equaling 31, and I'm doing this second step down here in red. So I've just worked out that y is 3. So 7y means 7 times 3, which is 21. So 2x plus 21 equals 31. Taking away 21 from both sides, I've got 2x equaling 10. Dividing by 2, I therefore get x equaling 5. Question 11. So the table gives information about the ages of all the 90 adults in a supermarket. So for example, 4 of the adults were aged between 20 and 30, 28 were aged between 30 and 40, and so on. So for part A, find the probability that this adult's age is more than 50 years. So more than 50 years old, we've got these 16 here are aged between 50 and 60. These 8 here are aged between 60 and 70. And these 4 here are aged between 70 and 80. So all 3 of these rows are aged more than 50. So there's 28 of those when we add those together. So that's 28 out of 90. Or if you want, you could simplify it to 14 over 45, but you didn't need to. Now for part B, complete the cumulative frequency table for these 90 adults. So this is a running total. 4 of the adults are aged between 20 and 30, as we know, but 32 are aged between 20 and 40, because that's these 4 here and these 28 here. So that 32's come about by adding the 4 to the 28, and then the 62, we just add on the 30 here onto the 32 that we've just got. So that 62 is the 4 plus 28 plus 30, and so on. Now when we plot this on the cumulative frequency graph, do remember to plot the upper boundary for the ages. So we're plotting 30, 4, and 40, 32, etc. And then just join them, making a nice gentle curve. Now for part D, use a graph to find an estimate of the number of these adults who received a discount. So these are for the adults who are with an age greater than 65 years old. So here's the age, here's 65, halfway between 60 and 70. Take a reading off your graph, and I'm getting 84. So the number who are greater than 65, it's these here between 84 and 90. So 90 take away 84, which is 6. Now the mark scheme does allow a little bit of leeway here, given your hand-drawn curve. So answers between 6 and 8 were allowed. Question 12. So to write this number in standard form, remember step 1, you need the first number to be between 1 and 10. So where do we put the decimal point along here to get a number between 1 and 10? Well, that's going to be between the 4 and the 5. So that's 4.51. And then it's times 10 to something, and it's a small number, so it's going to be a negative power. And then really you just want to bunny hop along from where the decimal point is to start with, here, to where it needs to be between the 4 and the 5. So that's 1, 2, 3, 4 hops. so minus 4. And you can always just check that by popping that into your calculator and pressing equals. Now for part B, kick off by doing this division on your calculator using that fractions button 3 down on the left hand side of the calculator, where you've got the white rectangle divided by the black rectangle, and that's going to give you this normal number solution. So we need to, however, translate this into standard form. So the same principle applies. Where do we put the decimal point to have a number between 1 and 10? Well, that's between the 3 and the 2 to get 3.25 times 10 to the something. The power is going to be positive now because we've got a large number. So the decimal point presently is right at the end, and it needs to move to between the 3 and the 2. In counting the hops, that is 9 hops. So 3.25 times 10 to the 9. And again, you can check the answer by just popping this in the calculator and pressing equals. Question 13. Now I think A and B are fairly straightforward, but part C is quite tricky. So here we go. For part A, we've got to work out the value of D, and D is the length of the base, but we already know the height. The heights, 12 and 8, they're mathematically similar, so this is just a smaller version of A. So let's first of all just establish what the length ratio. Well, the length ratio from A to B is 12 to 8, and just simplifying that, dividing by 4, we can say that's 3 to 2. So over for part A, we've got to work out the value of D, which is another length, so we're just going to be using the length ratio again, 3 to 2. Well, the length of the base of A is 9. What's the length of the base of B? Well, we can see that this ratio here is just 3 times bigger than our initial ratio. So 3 times 3 is 9, 2 times 3 is 6. So the value of D is 6 centimetres. Now for part B, we're now dealing with volume. We've told the volume of B is 160, and we need to work out the volume of A. Now we know the length ratio is 3 to 2 from A to B. The volume ratio is going to be this cubed. The area ratio would have been the length ratio squared. Length is area is 2-dimensional, so you square to get the area ratio, and volume is 3-dimensional, so you cube to get the volume ratio. So the volume ratio is 3 cubed to 2 cubed, which is 27 to 8. So bringing this volume ratio over here, I know the volume of A is, well, that needs to be worked out. I know the volume of B is 160, so I can see that my this new ratio is 20 times bigger than my starting ratio, because 8 times 20 is 160. So I need to multiply my 27 by 20 to work out the volume of A, which is 540. Now part C is tricky. We need to find an expression for the weight of Q, giving your answers in terms of lowercase p, q and w. Now weight is proportional to the volume, so really throughout this I'm just going to be considering the volume, and the weight will just follow accordingly. So I know that my area ratio is for this one, my area ratio is P to Q. P to Q. They're telling me the surface area of P is lowercase p, surface area of Q is lowercase q. So that's the area ratio. Now I need to find my way to the volume ratio. So how do I get from area to volume? Well, I square root to get back to length, and then cube this to get to volume. So area, 2-dimensional, we square root to get back to length, 1-dimensional, and then we cube this to get to our volume ratio. So the volume ratio is the square root of P cubed and to the square root of Q cubed. Now I'm told that the I'm trying to work out what W is the weight or volume of P, and I need to work out an expression for the weight of Q. So I know this is W. I need to work out this volume ratio, weight ratio for Q. So how do I get from here to here? Well, I need to divide by this and then multiply by this. Okay, to get from here to here, I need to follow this ratio. So if I divide by this and multiply by this, I work out what the volume ratio is for Q. So that's my final answer there. Question 14. So for part A, I need to simplify this. Well, the square root of x is x to the half, and then this is to the power of 8. So in a scenario like this, we just multiply these numbers. Half of 8 is 4, so that's x to the power of 4. Now, to solve part B, I really need to undo this division by 3 to start with, so I'm going to choose to multiply both sides by 3. So on the left, this undoes the denominator, just leaving me with the numerator, 6 plus 4y, and then I need to multiply both terms on the right by 3. 3 times 5 is 15, and 3 times minus 2y is minus 6y. So I'm now going to gather up all my y's on the left hand side by adding 6y to both sides, and then gathering up all my normal numbers on the right by taking away 6 from both sides. So that gives me 10y equaling 9. Divide through by 10, I get y being 9/10, or 0.9. Now for part C, to make G the subject, you've got to kick off by getting all of your terms including G on the one side, and all the terms which do not include G on the other. So I'm going to choose to take all my terms involving G to the left hand side, so I'm minusing GH from both sides, and then to get all my terms which do not include G onto the right hand side, I'm going to add 1 to both sides. So that gives me this. So now, step 1 achieved, all the terms on the left include G, all the terms on the right exclude G. So now I can factorize. This is the key bit. So suddenly I isolate and I've only got 1G. So factorizing my left hand side, I've got G multiplied by 1 minus H equaling 3H plus 1. I can then divide through by 1 minus H to give me my final answer of 3H plus 1 over 1 minus H. Question 15. Now we're told P is directly proportional to R cubed. So your first line of working needs to be this provisional formula, P equals K multiplied by R cubed, where K is an unknown constant yet to be found. Now had the question said P is inversely proportional to R cubed, this formula should read P equals K divided by R cubed. So multiply by K when it's directly proportional, and it's K divided by R cubed when it's inversely proportional. So that's step 1. Now step 2 is to find out what K is, and they'll always give you a moment in time to allow you to do this. So we know when P is 343, R is 3.5. So substituting those both into this, we get this equation, which we can solve by dividing through by 3.5 cubed, giving us K equaling 8. So our final formula for P in terms of R is no longer P equals K times R cubed. It's because we now know that K is 8. It's P equals 8 multiplied by R cubed. Question 16. So start off by multiplying out the pair of brackets. So this times this, this times this, this times this, and this times this, giving us this line here. Now, just simplifying this a bit, root 2 times root 2 is 2, 2 times 15 is 30. We've got 5 lots of e root 2 here, and we're taking away 3 lots of e root 2, so that leaves us with positive 2 lots of e root 2, and obviously we've still got the minus e squared. To finish the left hand side, and we're told that this equals f root 2 minus 6. Now if we then go and rearrange the left hand side to have our root 2 term first, so 2e root 2, and our non-root 2 term second, so that's 30 minus e squared, we can now do what's called equating coefficients. This number in front of the root 2, this coefficient in front of the root 2, must equal this coefficient in front of the root 2, so we know that 2e equals f. And secondly, this second term here must equal this second term here, so 30 minus e squared must equal minus 6. So focusing on this second one first, if we add e squared to both sides and then add 6 to both sides, we get 36 equaling e squared. And square root, we get e in theory being plus or minus 6, but we're told that e is a positive integer, so e must be plus 6. And then moving on to the other fact, we know that 2e equals f, so that f must equal 2 lots of e, 2 lots of 6, which is 12. Question 17. So we know p to q is vector a, p to s is vector b, y is halfway along ps, and x is halfway along qs. So for part A, the vector q to s, so that's a q to p and a p to s, so a minus a, as we're going down that the wrong way, plus a b. Now for part 2, q to y, well that's going to be a q to p and a p to y, where py is half of ps, so half a b. So that's going to be q to p, which is a minus a, plus half a b. Now p to x is going to be p to q plus q to x, bearing in mind that qx is half of qs, and we know the vector from q to s is minus a plus b from part I. So p to q plus q to x, p to q plus half of qs, so that's p to q is an a, and we're doing half of qs, half of minus a plus b. So then just simplify this vector here, multiplying out the bracket, so we have a minus a half a is half a plus half a b. Now for part B, we're told a couple of things. We're told that vector PR is 4 along and 2 up, x to v is minus 5, 4, and we're also told that PR is 2/3 of px. So let's just focus on this for a sec. PR is 2/3 of px. So up here, if I choose to multiply both sides by 3/2, in other words, 1.5 lots of PR is px, and I'm going to come back to that in a minute. So I need to work out the coordinates of v, so to start with, I'm going to work out what the vector is to get me from p to v. So that's going to be p to x and x to v. And I've just said that p to x is 1.5 lots of PR. So that's 1.5 lots of PR plus xv. Now PR is 4/2, so 1.5 lots of that is vector 6, 3, and x to v is minus 5, 4. So p to x plus x to v is this vector plus this vector. 6 minus 5 is 1, 3 plus 4 is 7. So the vector to get me from p to v is 1 along and 7 up. Now given that the coordinates of p is 3, 1, to get from p to v, to get from 3, 1 p to v, I've got to go 1 along and 7 up. So translating the coordinate 3, 1 by the vector 1, 7, I get 3 add 1 is 4, 1 add 7 is 8. So the coordinates of v are 4, 8. Question 18. So we're told that the number that are in A intersection B, so that's A and B, is 4. So that's where that 4's come from. We're told that the number that are in A in total is 5. So the A circle has got to have a total of 5. So given we've already got the 4 in the middle, that's an additional 1. And then we're also told the number in B is 9. So that's in the B circle has got to be 9. So given we've already got 4 in the B circle, we need an additional 5. And then finally, we're told that the number in the universal set is 50. So the total in the whole rectangle has to be 50. 5 plus 4 plus 1 is 10. So 50 take away 10 gives us the 40. Now for part B, for BI, the number that are both A and also not in B. In A, but also not in B. So to be in A would be the 1 and 4. But then also to be not in B only leaves us with the 1, because obviously that 4 is in B. So that's 1 is the answer for that. And then secondly, we're looking for ones that are in A or not in B. So first of all, those that are in A, would be all of the 1 and the 4. And then also not in B, well, that's everything apart from the 5 and the 4. So that brings into play the 40 as well. So it's the 1, the 4 and the 40, which makes 45. So just to go over that again, it's got to be either in A, so that's the 1 and the 4, or not in B, and that then brings into play the 40 as well. Question 19. So for part A, we've got to express the inverse function f to the minus 1x. So we've got to really change the subject of this function. So kick off by letting y equal 4 over x minus 3, and then we're going to change the subject so we end up with x equaling something. So start off by multiplying both sides by x minus 3, multiply out the bracket, we get this. Then we only want those terms involving x to be on the left hand side and those without x to be on the right, so I've chosen to add 3y to both sides. Then I've divided through by y, giving me x equals 4 plus 3y over y. Now remember, y is just something you've introduced to help you rearrange. Our final answer needs to be 4 plus 3x over x, because we're just changing, we're just rewriting this, we're just changing this function, and the function involves x, so the inverse function must also involve x. Now for part B, we've got to solve fg of a equaling 1. Now be careful, the first thing you do is pop a into the g machine and then put that output into the f machine. So starting off by putting a into the g machine, I get a minus 2 over a, and then I take this and I pop this into the f machine, so that's going to be 4 over a minus 2 over a minus 3. So I then need to tidy this up. So I've started off by multiplying through by this denominator, giving me 4 equals this. I've then added 3 to both sides, giving me this. I've then multiplied by a, and then taken away an a, and then divided by 6, giving me a equaling minus a third. Question 20. So the bag contains 12 marbles, 6 are red, 4 are blue and 2 are green, or if you like, 4 are blue and 8 are not blue, B dash not blue. So we're being asked to find the probability that exactly 2 of these marbles are blue when we take 3. So the ways that could happen, we could get blue blue and then not a blue, or blue not a blue blue, or not a blue blue then blue. So if you work through each of these in turn, so following this scenario here, a blue blue not blue, that's 4 out of 12 and then 3 out of 11. Remember, as you pick that second marble, there's only 11 in the bag, and then thirdly, as we pick a not blue, it's 8 out of 10. Or this is another way we could get 2 blues, a blue not blue blue. So that's 4 out of 12 for a blue, then 8 out of 11 for not a blue, then 3 out of 10 for a blue. Or a third scenario, to end up with exactly 2 blues, we could get a not blue, blue, then a blue. So 8 over 12 times 4 out of 11 times 3 out of 10. Now what you'll notice is that each of these 3 brackets have got the same numerators and the same denominators. The only difference is the numerators are in a different order. So a shortcut would have been to skip this purple line here and just appreciate that our answer we're looking for, given that these 3 are the same, is just 3 lots of any of them. So for example, 3 lots of the first bracket. So I could have sped things up by just saying my answer is going to be 3 lots of this bracket here. Anyway, we then do top times top, bottom times bottom, and once we've simplified it, we get 12 over 55. You'll see here that I've just done a little bit of simplifying before I multiplied across. 3 fours are 12, 12 divided by 12 is 1, leaving me with 1 lot of 3/11 times 8 tenths. Anyway, a final answer of 12/55 or equivalent. The question did not require us to simplify the fraction, so any fraction which is the equivalent of this will give you full marks. Question 21. So these 3D Pythagoras and SOHCAHTOA questions really just require you getting behind the 3D drawing and breaking it down into a few manageable 2D drawings. So we've been asked to calculate the size of the angle between VC and the plane ABCD. So just try and picture that. So we've got VC, and then we want to drop straight down vertically from V to create this triangle here. So at the end of the day, we're trying to find out this angle here between V and C and M. So that is the two-dimensional right-angled triangle that we're working towards trying to find out this angle here, which I've marked X. So as things stand, I know the height of this triangle is 7, but I don't know either the hypotenuse or the base MC. So what I'm going to do, I'm going to work out the length of MC by looking at the right angled triangle M to D to C, which I've drawn over here, and you'll see in that triangle M to D to C that MDC is a right angle and MC is the hypotenuse. Now we know the length DC is 18, and we know the length MD is half of AD, which is the same as half of BC, so 5. So looking at this triangle here, we can easily work out MC just using Pythagoras. MC squared equals 5 squared plus 18 squared, which is 349. So MC is the square root of 349. So I now know the length of MC being 349. Now that I know two sides in the triangle VMC, I can work out this angle VCM, which I've called X, by using SOHCAHTOA, because I now know the opposite and the adjacent side. So tan X, because tan is opposite over adjacent, is my opposite side of 7 divided by my adjacent side of the square root of 349. So popping into my calculator, 7 divided by the square root of 349, and then inverse tanning that, I get my angle being 20.541 dot dot dot. So to 3 significant figures, that is 20.5 degrees. And finally, question 22. So our approach here is going to be to factorize this as much as we can to start with. So my denominator here I can factorize by taking 2 out, give me 2 bracket x plus 6, because 2 times x is 2x and 2 times 6 is 12. And over here the denominator of this second term is a quadratic, which I can factorize. I'm looking for 2 magic numbers which multiply make minus 48, but add to make minus 2, so that's 6 and minus 8. So this factorised is x plus 6, x minus 8. So it's the bits in blue that you can see there. Now, in order to take away fractions, I need a common denominator. So I've already got an x plus 6 and an x minus 8 over here. So to make the denominators common, I need to have an x minus 8 in the denominator over here. So that's where that x minus 8 comes from. Now I can't change the fraction overall, so if I'm multiplying the denominator by x minus 8, I also need to multiply the numerator by x minus 8. So over here I've now got a 2, an x plus 6 and an x minus 8. And at the moment over here I've got an x plus 6 and an x minus 8. So I also need to have a 2 in the denominator over here to get the same common denominator. So I multiply both top and bottom by 2, so I'm not changing the fraction overall. So now that I've got a common denominator, I can just take away my numerators. So I've got 3x minus 24. Now you've got to be ever so careful over here. It's 2 times x and 2 times minus 15, which is 2x and minus 30. But we're minusing both of these. So it's minus 2x. And in particular, be very careful that you've got plus 30 here. we're minusing minus 30, which is plus 30. Now from then onwards it's not too bad. We just simplify our numerator. 3x take away 2x is 1x, x, and 30 take away 24 is plus 6. So I've got x plus 6 as my numerator. Now I've now got x plus 6, and it's both a term in my numerator and denominator, so both of these can cancel out. So basically dividing top and bottom by x plus 6. And just be careful, we've really got one lot of x plus 6 in the numerator, so don't forget you still need to have a 1 in the numerator. So our final answer is 1 all over 2 multiplied by x minus 8. You can multiply out the denominator, but I think it's best to leave it factorised like that.